please last the whole time. Okay, guys, we've got to get a move on. Okay, we've already wasted 5 minutes. We can't get that 5 minutes back. So, guys, we've got 2 chapters left until the holidays. We've got chapter 10 and we've got chapter 11. Chapter 11, very easy. 3 different reactions. Just take a double X.
Chapter 12.
Chapter 12 we do when we come back. Okay, so for chapter 10, guys, this is all about reactions. So we're going to be doing substitution, addition, combustion, and a whole array of new reactions that we didn't do in year 11. So let's have a quick look at the dot point. They want you to know addition reactions. Do you remember, is that with the double bond or the single bond? The double bond, very good. Does anyone else remember that? In addition, the double bond breaks and you have 2 things which come down and bond on either side.
Yeah.
Yes? And then you have substitution, which is just you remove a H and you plug on something else, whether it's a chlorine atom or whatnot. And then we have things like, when it says haloalkanes, it's just chloromethane, for example. That's a haloalkane. Oxidation of primary alkanols. I don't know if you've seen this before. You shouldn't have, because it's to do with alcohol. If you've left, say, your bottle of wine open, and then you go and smell it later, you smell, it smells a bit like acidic. No? Let's say, so if, guys, if alcohol goes off, if the cork has a hole in it or something like that, it can smell quite acidic. What you've actually done is you've oxidized your ethanol in there into ethanoic acid. So that's one of the reactions that we're going to learn, oxidation of alkanols. You can do propanol as well into propanoic acid, butanol into butanoic acid. Okay, so, and then we're doing esterification, which are the ones that smell. Okay, so what I want you to do, guys, is write at the top. So we're basically going to do a double-sided poster, and then you can photocopy the back side if you like, or you can just use it while you're studying and do one on each side. I just think, guys, we've got to work together here. So I just think that this is the best way to learn it, through a mind map type thing, because it's all different reactions, and we're going to put all the reactions on the one side. And then on the other side, we're just going to summarise what the important things that VCAR wants you to know about each reaction. Like, do you need a catalyst? What is the products? What are the products? So on one side, I want you to write at the top as a heading, summary of reactions. Just at the top, very small. Yes, Zach, please work with me. Summary of reactions. It doesn't need to be top middle. So pretend that this is your A3 paper, summary of reactions. Okay. In the end, your summary of reactions will look like something like that, and we'll have all of the different reactions. We've got the reactions that alkanes undergo, alkenes, and we've got functional groups over here. Okay, and then your back page will look even more impressive. How cool is that going to be? Are you excited?
Can we just get that one?
Okay, so I'm going to also photocopy my one for later. But the other class is coming along quite nicely. You're getting there. Alright, so guys, first of all, let's work on this side. We've got summary of reactions. We are going to be looking at the reactions of, try and take up as little space as you can, because we've got lots of stuff to do. So we're going to do hydrocarbons, and then we're going to do functional groups.
Is there only going to be 2 arrows up this?
Yep, they're the 2 arrows. I'll show you, I've actually taken a photo of it, and it looks like that. Hydrocarbons and functional groups. Okay, what are hydrocarbons again? Is chloromethane a hydrocarbon? No. So only C and H. What are functional groups again? Excellent, but their elements other, yes, than C and H. So obviously when you add a chlorine there, it becomes more reactive or reactive in a different way. When you add a hydroxyl group, again, different type of reactions. So under hydrocarbons, we are going to be looking at only two homologous series, and that is alkanes and alkenes. Okay, alkanes, let's have a look at them first. What are alkanes soluble in? Are they polar? No. Okay, I'm going to be doing demos as we go. After we've learned about it. Yeah, so probably Friday. Okay, so here I've got, I did this with the other class. So what I did was I had water in here and I just poured a little bit of cyclohexane. Excellent. So you can see that there's nice and clearly that there's two different phases. Yeah. So therefore it must be insoluble in water. But if we mix cyclohexane and octane together, you should get one phase. So although it's insoluble in water, remember, like dissolves like, so it's soluble in non-polar solvents. So alkanes are non-polar, soluble in non-polar solvents. Why are they non-polar? We kind of spoke about this at the start of naming. Why are they non-polar, alkanes? Yes, very good, but the carbon to hydrogen bond is slightly polar because there's a difference in electronegativity. But why as a whole is the molecule non-polar? It's completely symmetrical, very good. So it looks like that. You've got your H's, it's tetrahedral, and we have positive on this side and positive on that side and positive on that side and that side. So it's completely non-polar. So it's a non-polar molecule, and that's all we wrote. So it's non-polar and it dissolves in things like oil. Do you think that alkanes are reactive? Do you think they're not reactive? Excellent. So what did you say before that? Alkanes are... Yeah, alkenes are much more reactive because of their double bond. Very good. Alkanes have a single bond and it's actually highly stable. Okay? They're non-polar as well, making them very resistant to reaction. So you just say relatively non-reactive. It doesn't mean that they can't react, it's just that they react in a limited number of ways. Okay, bless him. There are two types of reactions that we're going to learn about for alkanes. How do we know how alkanes react? Sorry, what's one type of reaction that we've learned in year 11? How they react? Substitution, that is one. What's another type? Combustion. So I'm going to show you combustion here. It's a different one. That's all right, that's just water. So this is butane. Okay? Yes. Do you agree that it's part of the alkane homologous series? Yes. Okay, so let's see how it reacts. So I've just got a bit of detergent in there. I've done this with you before, but I did methane. Now methane, remember you get this explosion and then it just disappears straight away. It's very, very quick. Butane has 4 times the amount of carbons. It should last a little bit longer. Well, let's have a look. I'm going to do it over there near the window. Alright, so just take a look. Hopefully I don't. And you see it's burning for a little bit longer than the methane by itself. The methane was just like, and it went off straight away. So, we do get a combustion reaction. Okay. Do you remember about a combustion reaction? I go through like 40 pairs of gloves when I teach this. So I got my bag of gloves. Now, because I want to like write on the board, do you get what I'm saying? Okay, so we've got 2 types of reactions. Don't question me. Okay, we've got combustion and we've got substitution. Write as small as you can, because you can always blow it up. Not blow it up like that. Okay, in combustion, what can you tell me what it is about combustion? Anything, states, products, reactants. Excellent. O2, reactant. What else can you tell me about it? Jesse, pay attention guys, write it down as we go because I'm going to rub it off very quickly. Excellent. Products are carbon dioxide and water. What else can you tell me? Yes, all gas. And is there anything else about a combustion reaction? Oh, how did I tell you how to balance combustion reactions? What do you do first? Excellent, but what do you mean the water or the CO2? Because water's got oxygen. Do you mean CO2? Carbon first, then H, then O. You never do oxygen first because oxygen's in carbon dioxide and water. Okay, so that's combustion. Now, we're not doing substitution just yet, we're going to do it. Okay, what I want you to do under that particular column, like we're all working under that one part, you're going to do some examples of combustion. Pretend you're the environmental minister of Williamstown, okay, and you're deciding if Hot Wings should use ethane or propane to fuel their cooking of barbecue chickens. So what I want you to do to make your decision is write down 2 balanced equations to determine which hydrocarbon gas would produce less CO2 per mole of alkane. So you're doing propane and you're doing ethane. First of all, which one do you think would produce the less number of moles? Ethane. What's the mole ratio between carbon dioxide and ethane? 1 to 2. Whereas that between carbon dioxide and propane is 1 to 3. So, because carbon dioxide has 1 carbon. So what I want you to do is 2 balanced reactions under your examples. So I want you to put examples there. Ethane and propane. Let's go, you have a couple of minutes to do that. Under there, ethane and propane. Well, if you want to, if you don't think you'll get it right. Anyway, what I've been doing, guys, is dividing it into the columns, like to make it a bit neater. How would it be better to column? I got something wrong flat back there. Yeah. 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 But it depends on if it's an alkane or an alkene. Yeah. Okay, Zach, so guys, I'm only going to give you 2 minutes to do this. Very good. Yeah, that's what I think. I just but you don't have to. It's just that my brain is able. Okay, quickly. You do remember? Oh, well, can you please just do it to show me that you get it right anyway? Finish? Make sure you got your states. No, well you can join it on the next line. It doesn't have to be all in the one line. Yeah.
What's CPH6 called, gas?
Yeah. No, gas. You can do them all gas, or they also accept the state that's in your data book. So because they've put that in your data book, they have to colour themselves. And pentane you can put as a liquid, but regardless, propane and ethane are gases anyway. But if you put it as a gas, you don't get marks off because technically everything in combustion reactions is a gas, but they have to accept it. Oops. What have we got? Are we finished? Okay, can I go through the answers now?
Yeah.
So C3H8 plus oxygen, CO2, H2O, 3 carbon dioxides, and 4 H2Os. And then how many? 6, 10, 5 oxygens? Happy with that?
Oh, no, that's not one. That's the other one.
Why does it matter? 2 there. And then what's this? 3. And then what's that? 4.5. No, hang on. 7, 3.5. And then you go 2, 7, 4, 6. Okay, guys, something really exciting. In BCE, so in Unit 4 chemistry, they actually accept 3.5.
They actually what?
They actually accept 3.5. They used to not accept it in Unit 3, but now they have to because it's a combined Unit 3 for exam. So if you leave it as a 0.5, I won't be taking marks off for combustion reactions. Do you like that? No, just combustion. That's why.
If we do it so it's 7 and kind of even it out, we don't get marks.
You don't, no, definitely not. That's the more correct way. Yeah, but they accept it. Okay, so guys, are you happy with combustion?
Yeah.
Yeah, cool. So substitution, what I want you guys to do is come up to the fume hood. I'm actually going to get you guys to go into Santiago's way and going into the back entrance of the fume hood and just pulling up that curtain so you can see what's going on. Okay, so go over there. Guys, you come over here. Need more gloves. More gloves. Oh. Do you want to stay here? Okay.
All of us going there.
No, you guys are coming in through this way.
Right.
Okay. So, here I've got, whoops. Oh, did I leave my hexane now? Okay, here I've got cyclohexane and I've got cyclohexene. So I've got something with a double bond hexene and single bond hexane. So what I'm going to do is I'm going to put single bond here. So hexane, whoops, poured it all over myself. It's alright, I'll just blow myself up. A and E. And E. E is more yellow. Okay, so this is bromine Br2. Okay, now let's watch what happens when we put it in the A. When we react the bromine with the A. So bromine is red. However, put it in the A. Not much happens. E. Bromine is red. Every time you put it in, it looks like it disappears. True. Okay, you keep going and it makes the red colour disappear. Come back in. Come back in. So hard to talk through the fuel. Alright. We got this. Very red. Guys, I'm just no, come over here. Very red. Very red. The one with the single bond is very red. Okay? It looks like it hasn't reacted with the bromine. But if I add UV light,
Wait, I cannot see.
you can see it's starting to clear up. Only ever so slightly. Have a look at the top. So it's starting to react. You need UV light if you're going to react with an alkane because that single bond is so stable. So if I left it for ages and if it was a sunnier day, you'd see a bit more of a reaction. But are you happy that it's going a little bit clearer compared to what it was? Alright, let's summarise that. So go back.
Don't touch me.
Okay. So here we go. Substitution. Let me just rub this combustion off. Okay. In a substitution reaction, guys, you need to. Oh, I should put this back up. Whoops. Is that upside down? I can't even tell. Okay. Okay, in a substitution reaction, you need to have UV light as a catalyst. That's the first thing you need. Otherwise, you can sit there forever and you'll get no reaction. Ethane plus chlorine gas in the dark produces ethane gas plus chlorine gas. In other words, it doesn't react. So no reaction with you without UV light. If we add UV light, guys, this is what we get. Now we're going to draw this out, okay? So I want you to actually take up quite a bit of space for substitution because what do you mean? No, yeah, definitely write small, but I mean, you're going to be taking up, we're going to have a few more notes than combustion. So we're going to be drawing a picture. Now you've got methane here, that'll be our alkane that we're looking at. If that reacts with chlorine gas, remember chlorine is a diatomic molecule, has 2 atoms in it. Okay, what do you think the UV light does? Or can you remember what the UV light does? Excellent, it breaks the chlorine bond. You do remember, Paula. Okay, so UV light comes over here, breaks the bond. Oh, where's my purple? UV light, happy? Breaks the bond. How many, guys, how many electrons are in this bond? 2, very good. So when we break the bond, 1 electron goes to either chlorine. How many electrons does this chlorine have in its outer shell? 7. It's called a... No, an ion would have 8 electrons in its outer shell. What's it called? Free radical. Okay, a free radical means that, well, number 1, it can cause cancer because it can go into your skin to find that 8th electron that it so desperately wants. No.
When you just put the thing out the window and it reacts with the UV light.
Oh, yeah, but you weren't making cancer. Yeah, you're breaking that bond. Okay, so what happens, guys? What do you think that the chlorine can do, Zoe? Once the chlorine bond breaks, it has a couple of options. What can it do? Hang on. Your name's not Zoe. Your name is? Yours is.
I'm going to bond with the
Yes?
hydrogen.
All close, close. We've got 2 chlorines, remember, so they can both do different things. Yeah? So the chlorine could go back together, and sometimes it does. You have lots of atoms in there, all doing different things. So the chlorine can break apart. If it's near a methane, it can go, oh, there's electrons here. I'm going to just slide right into there.
Does the other one bond with the H? As in
Very good. So your 2 products, guys, is, or are, it's been substituted with 1 chlorine, and the other product is H and Cl. Guys, come on, writing this out. So what are your 2 products called? What's this called? Chloromethane. So we've made chloromethane. Is that its name, HCl?
Yes.
Hydrogen chloride?
That's the one. That's what I was trying to say.
No?
Wait, why not?
Oh, very good. How do you remember that?
Because acids and bases.
Yeah, but this is, it's hydrogen chloride because it's actually formed in the gas state. We don't have water in any of this. What I'm going to give you guys at the end of this topic is a little chart with how to determine states for all of these reactions. But I don't want to confuse it now. I just want to give you the chart, and it says literally, if you've got between 2 to 4 carbons and a chlorine, you'll be a gas. But then if you have more than 4, you'll be a liquid. So it gives you really the state for everything. But right now, We have to name it hydrogen chloride because it's not aqueous. Okay, so we've got that. Okay, so can more than one H be substituted? You can get more than one H substituted. This is called, guys, we've got to name this reaction. This is called a mono substitution reaction. That's called mono substitution. What do you think it's called when two H's are substituted? Disubstitution. Do you think that you can get this chlorine going there, that chlorine going there, and then hydrogen gas? That never happens.
No.
To get a disubstitution, you need 2 chlorine molecules, 2 moles of chlorine to 1 mole of methane. So, for example, okay, this one would go here, and then you'd have another one which goes here. And then how many HCl's do you get? 2. So it gets a bit messy like that, so I'm just going to write it out. CH4 plus 2 chlorine gas produces CH2Cl2 plus 2 HCl. That's what it actually looks like, summarized. Methane is a gas, and 2 chlorines would make this one a liquid. But don't stress about the states too much yet. So that's a disubstitution. Now, can you tell me what's a dead giveaway?
Yeah. UV light you've got here is actually on the H, and then the other one you've got in between the molecules.
No. Oh, that's not UV light. That's that attacking there. Sorry. The UV light, I did that in purple. Still attacking chlorine. Same thing, but it's just that you have 2 chlorine atoms doing that, molecules doing that. Yes, Gianni?
Why can't you have 1 chlorine atom taking the place of 2 hydrogens?
Because the hydrogens are sterically too far from each other to then bond together. They're not going to go from either side of the molecule and just bond together. It just doesn't occur like that. But a lot of the state thinks that. So if you don't think that, it's good. Yeah. No, because it's not producing something which is H+. It's producing a H free radical. It hasn't lost an electron, it's cut the bond in half. Okay, so we'll have a look at a little bit of evidence from this experimental evidence. If I could use chlorine, I would, but I can't because it's toxic. But what they've found is that if you add chlorine in the dark, you don't get a reaction. They've found that if you add chlorine in the presence of UV light, you get a reaction. But they've found if you add more chlorine, so 6 times the amount that was added here, you get this type of reaction. What's the difference between those two? So between this and this. Excellent. So there's no way to control whether you're going to get a mono or a disubstitution reaction. But if you put less chlorine, you tend to get the monos. And then if you put more chlorine, you tend to get the di, tri, tetra substitutions. So there's no way to control it because remember, you've got billions of these atoms, molecules, and then you've got billions of those molecules reacting. But they also found something else. They found that if you add bromine, even when bromine's largely in excess, they found that you only really get a monosubstitution reaction. And they found that with iodine, even when we put it in complete excess, you don't get a reaction. Ever. Anything. Ever. Why do you think that's the case? Why do you think, well, first of all, which one's the most reactive according to this of the halogen? The chlorine. And which one's the least reactive? And why do you think that's the case? Excellent.
It's further away from the core, which means the words and stuff. So, yeah.
Yeah, how do non-metals react? By gaining electrons or by losing? Gaining electrons? And are you more likely to gain electrons further up the groove? Yeah. So you get more reactive as you go up, and it makes sense that we get these results. That means fluorine should produce lots of different substitution products, even when we only have a tiny bit. Yeah. So we do get exactly what we expect. But importantly, what's the reaction initiated by? Is it initiated by the halogen, or is it initiated by the alkane? What initiates the reaction? Excellent. So it's splitting the halogen. So iodine, even if you have UV light, it must not be enough to split that iodine bond. Okay? Very strong bond. Very stable. It's not really strong, it's about stability. It's stable as a bond rather than separate. Okay, so we've got alkanes. We've got these two different reactions. Are you happy with that? Substitution and combustion. I think I've got just a little summary of that for people that are away, but we've written everything in there. Note that your textbook talks about halogens as X. They just write it as an X. So if you see HX, it's H and any halogen like chlorine, iodine, fluorine, or whatnot.
Whether it reacts depends on which one it is, doesn't it?
Yeah, it does, but they represent it as an X, even though,
And you just
yeah,
accept
you're
it as
right,
a reaction.
iodine couldn't be in there. Okay, another thing that is really important is you need to make sure you always write your catalyst of UV light on top of your arrow. So can we add that in and just make sure you write UV light, so you write any catalyst on top of the arrow. I think we did that in year 11 as well. Did we not write UV light, that it needed UV light? Yeah? All right, so UV light. Okay, an example of a VCAR question is this. They tell you a whole lot of unimportant stuff, and then they say the number of different compounds that could be formed in this monosubstitution reaction is what? And what I want you to do is think about it and write down an option. Do you guys know how to work that out? Yes? No? You've one chlorine. So what's a monosubstitution reaction? Yeah, very good. So how many, it's asking how many possible products are there when you substitute one chlorine with one hydrogen? Okay. Now, you could replace it at the end to make it 1, 2, 3, 4. It's still a butane. I'm trying to think of the name. It'd be 1 chloro, 2, 2 dimethyl butane. Now, if you replaced it with a chlorine up at the top there on that methyl group, Would it make a different compound to what you were saying?
So
Yeah. Yeah. So you're replacing the H there. You've got to think about would they produce different isomers? Yeah? Think about it like that. Give it a go. Can you work it out?
Oh, wait,
Is the top right and the one over there different? Who did you have? You have, yeah. Guys, do you have an answer over here? What do you have? Only two. Over here? Three? Over here? What do you guys have?
I'm gonna go. No, I'm not sure.
Really? It's not too bad of a question.
I didn't understand the topic.
You don't, it just says 2, 2.
Hydrogen atom of dimethylbutadiene.
Yeah, is replaced by one. That's a mono-substitution reaction.
Oh, I thought it was like saying what is the single.
No, I understand what you mean. No, how many different types of compounds could be formed by this mono-substitution reaction? So we could put a chlorine here.
Oh, so it's like isomers.
Exactly. You have to look at how many isomers are there with one chlorine there. So we got one here. If I put one here, will it be different? Here?
No.
If I put one here?
Yes.
So I can put one here, here.
Yeah.
3 only. They accepted 4,
I knew it.
not for the reason that you, or maybe for the reason that you think. Why do you think they accepted 4?
They were accepting like all 4.
No, they only accepted 3 of those.
Including the one they gave.
The leftover.
If you put it on one of the double bottom ones, it changes the chain.
No.
You could also
What else is
you could
reactive?
also make like an
No.
enzyme kind of group fish, like methyl.
HCl is also produced, so they said we have to technically accept 4 because HCl is also a possible product. Yeah, they need to be more. No. The answer was they accepted 3 and 4. They wanted 3, but they go, oh, well, the way we asked it was a bit misleading. They should have asked how many different alkane products are there if they wanted that. So, guys, importantly, this gives us a really important point. How many products are produced in a substitution reaction? 2. I want you to put a little hashtag. 2, that's not a hashtag, whatever. 2 products. That's how you can tell. In substitution, you always get 2 products. Because something substitutes the other thing. 2 products. You're going to see it's different with the other reaction that we're doing. Okay, so guys, we've finished for alkanes. Alkanes can only undergo substitution and combustion.
So we actually finished. We're not going to go back.
No, we're not going to go back.
I can draw lines underneath it.
Oh, you mean adding new stuff? You can draw lines.
Yes, all right.
Okay, alkenes. Alkenes, we know have the double bond. Are they polar?
No, yes, maybe.
Non-polar?
Yeah, that was one of my answers.
Are they reactive?
Yeah, yes.
More reactive? Than alkanes. What makes them more reactive?
Double bonds.
Excellent.
Unstable.
Equals is unstable.
I
Okay, so what type of reactions can they undergo? Addition, very good. And what else?
Substitution.
No.
Combustion.
Combustion, very good.
But don't they just do substitution at UV light?
That was alkanes. We've moved on to alkenes now.
UV light.
That was the alkane.
What could do without UV light?
Alkenes. That's called addition.
Well, that's what I meant.
Well, you said substitution, they're totally different. So combustion and substitution. Oh no, addition. Now you're confusing me. No, just kidding. Addition. Okay, so combustion, guys, we are not going to go through. Way too easy. Exactly the same, except for, if you want an example, C3H6 plus O2 produces CO2 plus H2O. Same thing, the only thing different will be the balancing, because you're going to have an alkene as opposed to an alkane.
And if you just want us to write about reaction?
If you would like to, or you can just write same as alkanes. Addition's the one that we really have to work on. Okay, addition. We've got our double bond here. Do you need UV light for addition of chlorine? Did I need UV light when I poured bromine in there? No. Okay, so there are a few types of additions that we're going to do. We're going to be looking at 4 different types of additions. So we're going to have to fit that under that spot. Even if you want to take up a little bit of extra room, I'm telling you now, we're doing 4.
Wait, for in addition.
Yeah, yours is fine. Alright, so we've got...
Do we need any more room for combustion?
Sorry? Now you can add to your combustion category with the... Guys, because we don't need any more room for combustion, you can kind of add to that space. We need heaps for addition though. Okay, addition. For example, so the first one we're going to do, actually, first of all, how many products do you get with addition?
3. One.
Only one. You add the 2 together and they combine to make a full compound. So it's only 1 product. UV light not needed. Okay, now we may want to put in the first one, we may want to talk about addition of halogens. As X2, so example bromine, or HX, for example HBr. So addition of halogens. Okay, so when you have your double bond, guys, what do the double bonds do? Why are they so unstable and ready to react? High electron density, yep.
Oh, it makes them want to move away from each other.
Excellent. The electrons want to move away from each other. Now, if they do that, so you never get both bonds breaking. One bond remains intact. The other bond, if that breaks, how many electrons have you got in there? 2. One electron goes here, the other one goes there. So let's say, oh yeah, we've got bromine nearby. The bond breaks and you get 1 electron here and 1 electron here. Now, How many electrons are around each carbon atom? Count. 1, 2, 3, 4, 5, 6, 7.
And you can take one electron.
What's that called?
That's cool. You've got seven.
Free radicals!
A free radical. It creates 2 free radicals. Okay? Yes.
It's a single bond between bromine that has 2 electrons in it. One can go to each of the single electrons and make one.
Exactly. So this ethene always does this. And it can go, oh, I'm going to go back, make a bond. It can do that all the time. But if a bromine's around and it splits, it goes, oh, there's electrons there. I'll grab one. And what it does is it breaks that bond and steals the bromine. So you do get the addition of bromine at each bond, at each side of the bond. Okay? So an example we're going to do is this. We're going to do propene. Why was I going to say ane? All right, propene plus HBr. You need to know how to be able to write out the products for those. How many possible products are there for that? Is there just one type of products that we can get? Really? Oh, sorry. Sorry about that. All right. I thought I broke something. I should just stop walking around. All right, so we break the bond. Where does the H and the Br go? Oh, because you can do both. See there, addition of halogens, you can do it as H halogen or Br2. So you get that bond breaking, 2 free radicals. The H can go here and the Br can go here. Or, yes, the Br could go here and the H could go there if it reacts with it flipped that way. Okay? So we only get one type of product at any given time, but there's 2 possibilities.
The isomers.
They are isomers. So I'm just going to write that out in green. I've got that in my hand. What am I doing? So this, or you can write out your other one. Or BRH. One product, 2 possibilities. Yes. Yep. Yes. Yes. What's the name, guys? We had a good question. Someone asked what the name would be of these products. Let's name them. Chris, you can go because you're talking a lot.
Okay.
Name this one.
One bromo propane.
Very good. No, aim. Listen to your gut. All right. And here we've got 2 bromo propane. Propane. Yep, they're the names. Perfect. Okay, second type of addition reaction. Sorry?
The one where it's BR2 that has it.
The other possibility. Oh, so you know how the H can go here? Yeah. Okay. Now in VCAR, guys, they've asked a question about how, if we have two unknown samples, we want to know if there's actually a double bond in there. Is there a way you could use what you know so far to determine if you've got a double bond in your sample?
Reacted without UV light and then reacted with UV light to see if it does it or
Yeah. But isn't the one without UV light just going to tell you straight out?
Yeah.
Because if you get a
But
reaction...
no, but then to double check, you should just test it with UV light, and if it doesn't do it that way, like, well, what am I doing with my life?
yeah, then you don't have an alkane or an alkene.
Exactly.
Okay, so guys, this is often known as the, in NEEP, test for unsaturation. That means if you have a double bond and it goes clear, like we just showed you before when we were pouring the bromine in and it went clear, it meant it had a double bond. Whereas with the alkane, I needed to hold it out of the window for it to start turning clear. Okay, second one. I'm going to be writing under here, guys, because I can't fit it all on the one thing. Okay, so second example, what else can we add? Can you guys remember any other things that we can add at the double bond? We can make an alcohol. We can react with water. It's called hydrolysis.
I'm surprised you guys can pick up on that.
Alright, Jesse.
Oh, you guys like by nerves. I would think that you'd be like, oh my god, water in the cup.
So you react, guys, if you react with your double bond and you react it with water, how do you think this works? Where does each of them go? Actually, I'm going to do...
Condensation.
Sorry?
Condensation, do it the other way. Same.
Please, let's just get on with this. So, if you're adding water to it, and we can only produce one product, remember? What do you think our product will be? It is an alcohol. This OH, guys, goes to one side, and this H goes to the other side to produce ethanol. Now, this is not ethanol that you drink because it will be 100% ethanol. It's used for alcohol wipes and things like that. No, not those ones either. All right, so we've got our product is like so, OH, H, and
Wait, I need the circling and the arrows.
I'm just showing you where the OH is going to this side and the H is going to that side. So this is called ethanol. Now you do need to know a little bit about this reaction, i.e. the catalyst and the conditions. So on your arrow, you write the catalyst, H3PO4, phosphoric acid. Do not ask me why VCAR wants you to know this. It seems like pointless pieces of information. And you need the reaction condition of 300 degrees Celsius to be able to produce ethanol.
What?
Yeah.
How does
When I learned it, it was 330. They must have just rounded
what's
down.
the chief assessor for chemistry?
Sorry?
What's the name of the chief assessor for chemistry?
We'll look up and go to a house.
Chris Dwyer, it's a dude actually.
Huge.
Is it you, miss?
Huge.
I wish.
Are you ever going to go for it, Miss?
Maybe.
It's you.
Huge.
Okay, ethanol demands are high. Here we go, that's the reaction. Ethene plus water produces ethanol. Note, one product. Why is it one product? Because it's addition. You're just breaking the double bond and then you're sticking things on either side of the double bond. Okay, third one. This one's a funny one. Addition of H2. Have a guess what we call this. We don't call it hydrolysis because we're adding hydrogen gas. What do you think we call it?
Hydrolysis.
No, because that's water.
Hydrogenolysis.
Oh no, close.
Hydrogen. Hydrogen.
It's hydrogenation.
I was actually going to say that, but I'm like, no, that's so stupid.
Oh, okay then. Hydrogenation. So you've got your ethene. It's so stupid.
It sounded ridiculous.
It's not ridiculous. It's correct.
Like my thought was right, but
Okay, so you add your H2. Zach,
Yes.
if you add hydrogen at the double bond of ethene, what do you get? Yes, ethane.
I didn't realize I whispered.
So moral of the story, you can add a lot of stuff to your... Okay, so guys, we've made ethane out of ethene. Why would we want to do that?
We're fine. To make it more stable.
The questions that you're going to get asked in this topic are things like, you start off with propane, then you want to make propanoic acid, and you have to go through all of these different steps to be able to do that.
I hated it.
Oh, maybe because you did it before we taught it.
That, but it's also because I hate it.
You may like it now.
8 reactions we need to get to get there.
Aww. Just relax. Oh, hang on, guys. Catalyst for that reaction, for the ethene to ethane, is you need a catalyst of platinum, lead, or nickel. I led my nickel to the platinum.
Yeah. Miss, what's the...
Unfortunately, guys, this part of Chem is memorizing. I know. If you couldn't tell already. H3PO4, phosphoric acid. Yeah, I led my nickel to the platinum. Beautiful. Wow. I like his boxes there because it's neater. It's good. Okay. If anyone walked in this room now, they'd be like, okay, I'm signing out Jen. Imagine the year 11s right now. Poor kids.
they don't know what this is.
They have no idea.
It's like, I have funding.
Yes, but how difficult did you guys find it when you're in year 11? You can't deny it. It felt hard.
What is this?
Just this?
Yes, leave that, please.
Okay. Okay. Now that we've done, guys, leave a tiny space for that number 4. That number 4 is addition polymerization. That's like, remember we made the polymers, polyethylene, styrene.
When you do the brackets, it's a thought.
Yeah.
Was that when we held hands and it was really awkward?
I don't
You know, when we
know.
like made lab track and we all to hold hands and everyone was so awkward about it?
Yeah, why
That
is
was
that
so
more
funny. That was the funniest day because I was like,
That was the funniest day. Alright, so flip your poster, guys. Flip your poster. Before we do number 4, we're going to summarize these.
There's all polymers in
Guys, come on.
Sorry, okay.
Please. Flip your poster. So on this side of the poster, we're just doing the theory. On this side of the poster, we're going to do practically what it looks like. And we're going to have, I don't know, 3. I feel like that's a good one. Propene and propane are going to be our starting reactants, okay? I just feel like it really, this is what it's going to look like in the end. Mwahahaha. Look at how cool that is.
No. Abort mission, no.
Oh, it's there again. Okay, so guys, bit by bit.
I'm done.
Come on.
Not the bottom bit. Sorry. Okay.
Come on, quickly. Okay, on the back of your poster, I want you to write.
You want us to write on the back?
Yeah, the back will be. Do you want to have 2 separate papers? One for each of the posters? I just have mine, one on the back, one on the front. Because you probably should write it out again and again to memorize. Are you just going to do that? Cool. Okay. Guys, what I want you to do is right at the top, reactions of organic compounds.
Catalyst of platinum, lead, or nickel.
Yeah, so is lead and nickel.
Yeah. Oh,
Yeah,
you got
we
it.
need lead and nickel.
Oh, you didn't know that platinum was an element. Okay, so guys, we've got reactions of organic compounds. What we're going to do is we're going to do a big mind map of all the different types of reactions, okay? Just the ones we've that we've done so far, and then we're going to add to it in coming lessons. So what I want you to do, and I'm going to show you, I think what didn't really work that well last year is because I didn't show anyone the finished products, so people had all different things. But we're going to start with propane. We're going to do propane. Pretend that this is your A3 piece of paper, and we're going to do propane here. Don't try and copy out the whole poster, obviously. Propane is here. I think that different colours work really well for this. So I'm going to be doing red, I'm going to be doing the reaction type. And in blue, I'm going to be doing the name of the compound. So here we've got, what's the name of this? Propane. What can propane react with? Remember, it's an alkane. What type of reaction? Combustion and substitution. Very good. So up here, guys, I'm going to be doing a combustion reaction. Look, I've even circled it. Yes. Okay, so propane by combustion, what's the reactant? I'm going to be doing reactants in green. What's the reactant of propane combustion? Reactant. O2, very good. What does it produce? CO2, H2O. You can balance it if you want. You don't really have to. It gets a point across, but I'll balance it because I've already balanced it over there. 5, 3, and 4. I want to keep it the same colours actually. Okay, happy with that? Guys, come on, because we've got 4 more to do. Are you happy with your propane? Okay, propane can also undergo substitution. What can it substitute with? Oh, wait. What did we prove experimentally? You can't do iodine. So, it's called substitution. You can do, we do X2 where X equals a halogen. So for example, bromine, fluorine, chlorine. Oh, I nearly said iodine, but I stopped myself. Because iodine experimentally it doesn't work. So guys, we're going to choose chlorine as an example. Now guys, if we undergo a monosubstitution reaction with propane, how many different products are there? Different possibilities are there for the alkane? Chloe, if we substitute one of these H's with a Cl, how many different possibilities are there for our alkane? Very good. What will the names be? Very good. Why didn't you choose, if it goes here, 3-chloropropane? Good. 1-chloropropane. Okay, cool. So, guys, when you substitute, we're just going to be doing a mono for an example. Otherwise, really, we're going to be here all day. So, you could have your chlorine. What was the worst, Zach? Oh.
What's your favorite pen mix?
My favourite pen? I really don't like those gel pens.
Wait, which gel pens? The ink joys?
I don't know, just gel pens in general. They always run everywhere for me.
What's the number in front of the H2O as a combustion reactant?
4. You should be able to do that, Gianni.
I know, I just should be above it in my hand. I failed.
You don't have to apologise, it's okay. All right, hang on guys, we're not done. What's the other product of the chlorine being substituted? HCl, very good. Plus HCl. Plus HCl. Okay, they're the only possibilities with propane. Let's do propene now. And now I'm going to put propene up here because propane has a lot more variety, because remember you can add tons of things to it. So propene, just where it's boxed. I didn't even intentionally box it like that. I did really well with that. Alright, so okay, what type of reactions can propene undergo?
Substitution.
No.
Addition and combustion.
Addition and combustion. So this is propene.
Oh, is that in the middle, like right under the title?
Yep. I'm drawing this one.
Really drawing? Why is it a big table?
Yeah.
What do you mean?
Why is it all linked together? What does that mean?
Because it's one. So in VCAR, they often ask.
Oh, fine.
Can I just say, sorry, Gianni? In VCAR, they often ask, can we get this, can you tell us how to produce this ester from propane? And you have to go through this whole pathway and draw a flow chart as an answer. Their questions are often a flow chart. So that's why we're doing it as a flow chart.
So if you have this table, you can answer everything.
Yes, that's what I mean. This will be the all-encompassing VCAR cheat sheet that you can't bring into the exam. Depends. The number of steps will be the number of marks. Okay, so propene, guys, because we're not going to lunch until we finish this. So propene can undergo a combustion reaction to produce CO2 and H2O with oxygen gas. Okay. It can also undergo a lot of different types of addition reactions. Let's say that we add, I'm going to do that one there, that's HCl, H2O. Okay. Where is my green? Okay. So, let's say that we add HCl. What are the two possible products when we add HCl to propane? You can add your HCl. What's the two possible products? Sorry? What's the two possible products?
There's just two types of the one chloro, two chloro.
Excellent. 1 chloro and 2 chloro. Is there only one product? Yes. It just has two possibilities. Okay, so with HCl, you can produce 1 chloro or 2 chloro. I'm going to fill in the H's in a minute. This is 2 chloro. Okay. Now, if we add H2O, remember that these are all called addition reactions.
Can't we do one of the H's on the first one in the green as well, because it's from the HCl?
Oh, very good. Yep. So that would have to be here, yeah, and then that one would have to be here. Yeah. No, that's good. Okay, if we add water to propane, what are the two possible products? If we add water to propane, what are the two possible products? 1-ol and 2-ol. Very good. What do you need with your water reaction? There are a couple of catalysts or conditions. Excellent. So I'm going to be doing that in purple, catalyst or conditions. Okay, so H3PO4 and 300 degrees Celsius. So 1, 2, 3, 4, 5, 6, 7. So H2O will be H2O or like this. So propane 1-ol. Oh, I didn't keep my blue. Get my blue from there. So propane 1-ol, propane 2-ol. What else can we add to our alkene? Hydrogen gas, very good. So if we add H2 gas, it's also addition, and it's called hydrogenation. This is called hydrolysis. Oh, hang on, guys. Have you written that? It's just an easier way that you could do it. You can do it over here, but what does propene turn into when we add H2? So you could just do an arrow pointing to the propane. So linking it in with that. So let's say VCAR says, how do you turn, you could go through this pathway turning it into propane first. So I'd go hydrogenation, and we'll go H2 as a reactant. What else is needed for hydrogenation? Have a look.
Platinum or platinum.
Very good. Nickel, platinum, or lead. Okay, what else can we add? HCl, H2O, H2. What else? What did we do in the fume hood? What did we add in the fume hood to our cyclohexene? Bromine. So if you add Br2, there's only one type of product, isn't there? Sometimes, guys, this is called bromination, halogenation, chlorination.
You're not really good for it.
No, I'm serious. I wouldn't lie to you. Sometimes it actually sometimes is. Like you'll see, guys, you'll see these quirky names in NEEP, because NEEP love to just use all. You know how we call things monoprotic acids? They call bases with mono-H monobasic bases.
So basic.
No, well, it's not that basic, 'cause it's only mono. All right, so we've got H, 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 and then we've got Br.
Oh dear. Addition bromine.
All right, what do we call this guy? No? Dibromo. 1,2 dibromo propane. Oh, this is cute. Looking good. Look at that. Isn't that just a work of art? I like the colours because
I like the colours, but I got like purple for your blue, and then I started writing purple when it should have been this.
oh,
Just ruined it.
it's okay. I just use different colours because it helps me remember things.
Yeah, I just didn't have one of them, so I substituted colours and added it in later, and all my colours got
Oh, I use purple later. Okay, so guys, we've done this, these, and these. We are going to do 1, 2, 3, 4 next lesson, and then we're done. Yeah, we're not going to do it now, is it okay? Yeah, that's everything on chapter 10 once we've done that. Oh, hang on. VCAR question.
No, wait, I'm still writing it down.
Oh, okay. Well, when you're ready, answer the VCAR question. Guys, write down your options. Okay, when butene, when butene forms a product for addition. Remember that? Okay. What is it?
C.
C?
Oh, yes, big.
A. Girls at the back? B? Because you have your but 2E. Yeah? It can never, guys, you can't ever have the 2 chlorines off the 1 carbon, because remember 2 free radicals, boom.
Excuse me,
They grab
teacher,
it
sorry
on
for
each
the interruption. Just a reminder, there's an SRC meeting in L1 today at the very start of lunch. An SRC meeting in L1 at the start of lunch. And could the following students please come to the office when the bell goes? Alex Kustianis, Lily Dyson, Gus Picking, and Chloe Bentley. Thank you.
Polymerization?
So excited.
Polyethylene. Remember that you still, even though there's no double bonds anymore, you still call it polyethylene because it's from the monomer from which it came.
Oh my god, I just remembered what it was. Yeah. Try to remember what it
Polystyrene.
was. Just like a bunch of stuff comes together and all after the
And then you put the brackets and the dot dot dot.
Viscous.
Oh guys, do you want to give me these or will you bring them back? Oh yeah, I will have yours. Yeah.
Oh, this.
Do you have your chapter 6? Show me chapter 6 and you can get the circle back. Okay. Yes, Zoe, I'm coming in 1 second. Let me grab this. Okay, who hasn't shown me? Thank you. Okay. Tom's not here. Sam Kelly. I need your